Hello everyone, welcome to Endless Codes. Today, I'm going to share a secret those pesky ETL people don't want you to know. Yeah, if you try to do this at a modern environment where they're doing ETLs, they're going to look at you like you're crazy. However, the bottom line, we need effective, realistic solutions that are cheap and fast. And this code is going to use SQL Server and C#. What we're going to do is we're going to create a database in Amazon RDS. Then we're going to populate a table with C# in RDS. And then I'm going to show you, dear viewers, how to write a really slick ETL process, taking advantage of bulk insert and some really crafty SQL. And I've used this literally in production at insert name of company here. It's been in production for over a decade and it's worked fantastic on a massive set of tables. So the fact is it's got some social cred, it's really effective, and you're gonna get a lot of blowback if you try to implement. But I felt, hey, Endless Codes isn't about just doing the tutorials everyone's doing. Endless Codes is about showing you cool techniques to do cool things, especially with data, because, you know, I love data. Apologies, it's gonna take a little long for this video because I've got to create the database, I've got to write some code, I'm going to show you the entire process. You may see some cuts in the middle. The cuts are primarily waiting for a spin up or because I just royally messed up and I want to back up and look perfect. We'll see how many of which each we do. All right, number one, log into Amazon. Give them your credit card and your life and cross your fingers that I don't overbill for you, all right? Click create a database. We're going to create an SQL Server database, and I'm not going to get ahead of myself. We're just going to make a tiny database because we just want something temporary. SQL Express, that's the free edition. Doesn't matter the version. Doesn't matter the identifier. Admin. And because this is a temporary database, let's do something horrible and make a simple password, 12345. Don't worry, when this video publishes, this database is going to be gone. All right. Small as possible, because I don't want to waste any money, or I don't want to spend any money. This isn't a waste. I really enjoy doing these videos for you. Default. I don't need auto scaling. I probably should, but we're not gonna deal with that. Don't need. Okay, I have set up for public access. Yes. And the reason I'm going so slow is I can't remember if I've already done this before. Yes, I have. There's my SQL Server VPC that I was looking for. It's already made the security public, so the moment we create this and it's on, we should be able to connect like that. If not, you're going to sit me watch through doing some tutorials finding out exactly how to set up that. Availability zone. Who cares? Don't need a proxy. This is just temporary. We're not going to use SQL or Windows authentication. We're just going to log in with our admin password. And actually, let me scroll up here. I'm going to write this down because I might have actually forgotten. See, look at that. It doesn't even match. I thought we were pair programming here. Y'all should have told me that I didn't write a password that's long enough. All right. It's going to go admin. And the password is, well, now I'm not going to tell you the password because I gave a different password. Notice I'm writing down on pen and paper here. And this is one of the most important tools a programmer has. We can write in pen and paper. It's fantastic. All right. Scroll down. Zone. Don't need performance insights. Let's click create. All right. This is going to take quite a while. And while this is being created, dear viewer, if you want to do this on your own, follow through what we just did. I didn't show you how to make the VPC, so you're going to have to look that up on your own. And go download SQL Server Management Studio Express. I'm going to show you what it looks like. This is the main console of Management Studio. It's absolutely free from Microsoft, and we're going to use this to query and design our database so we can visually see what we're doing. If you're an expert in SQL, you can just open up an SQL panel and manually type SQL to do the meta updates. But this makes it really, really easy, and it's a nice slick tool, and I want to give the viewers an introduction to this tool. Still creating. Hit refresh. While this is creating, you do your exercise. I'm going to wait. I'm going to come back in a little bit when this is finished, and then we'll see. Actually, you know what? I don't have to come back. We can write some code in C#. Right. So what I'm going to do, I'm going to open up Visual Studio, and I already have a console project written. What I'm going to do in this console project is write the base stub code necessary to connect to SQL Server. We can't test the connection yet because the database isn't online, but once it is, this will work just fine. And once this code's written, we're going to use this code to insert the initial data into the database, and then we're going to change this code to do the trick that I'm showing everyone. All right. Let's write some bad code first. The reason you shouldn't do this is because it makes it difficult to inject, but since it's a very simple project, I'm going to make a static class for my DB connection. It's an old habit. It's probably not a good habit. And we see here that SQL client is not included. So let's go to new Git and add the SQL client. Let's accept without reading because we all do that. And now we should have SQL client. I don't know why it's not working. Let's go check that again. Oh, they changed it. There you go. I'm so used to doing this the old-fashioned way. All right, I think this is going to make better sense. And what I like to do here with this class is I just want something to give me an open connection so I don't always have to go to our connection stream. When we get the connection string, we'll put it there. One thing to note here is we're writing this code. This opens a resource, and this isn't written in a using block. You're going to see later when I call this method, I always wrap it in a using block. But for now, just be aware that we're literally opening a connection. And if this code were runnable, it would keep that connection open. Not a good thing. All right, we've got our open connection. This means we could now actually execute against the data. We don't have anything yet, but I'm going to show you briefly how we can do this really quickly with with the code, but without actually doing anything because we can't run the code yet. So I don't like this. I'm sitting here thinking of how I'm going to do this. So I'm just going to load data table. I have no idea what the name of our table is going to be. And you are now seeing one of my biggest frustrations in the world, and that is that I can type, and for the life of me, I cannot disable extra parentheses in Visual Studio Code. It constantly inserts on me. All right, we got this. We want to load our table. How would we load our table? Well, we need our using statement. This gives us an open connection. Some of you watching might be arguing for ORMs, but bear with me. We're going to get to some real code, and I don't like using ORMs, so I'm actually showing you the rawest, fastest method for doing these operations right now. So trust me a bit, but you can use an ORM for most of this. ORMs are object relational mappers. I don't like them. A lot of people do. Okay, we've got an open connection. The next thing we need is something called a command. Commands are executed against the database. So let's create a command object. And a command can be as simple as a straight up SQL command. And here I'm just selecting star from our food table. Any suggestions what table we should create? Because I haven't really thought this video through. I don't know the name of the table I want. I don't like customer because customer is not big enough for this method. But maybe we can just do customer for now and just know that you probably don't have enough customers to use this method. We'll say, okay, we can get our customers. And we're going to pretend that our customer only has a first name, a last name, and cheat again because I like embedding SQL statements directly in code. I also like them to be well formatted. And using that @ sign gives us multi-line strings in C#, which is really cool. We'll have our customer first name, we'll have our customer last name. And well, you know what? Since I have you here, why would we even do this? We should just have a name. So remember, the reason we have last name and first name is for sorting and filing back in the last century. Now that we have databases and we can query, we don't need two separate columns for names. We just need a name column and we can query against it. So we'll have a name for our customer. And for this example, we will have a create date, which is when this record was created. We will have a last update date and create date, last update. To satisfy those ETL nerds out there, we're going to have a process ID. I'll just say process ID. This is the batch ID, there we go. We'll have a batch ID to identify when this was updated from an ETL. And this represents the entire customer table that we're about to create in the future. What I can now do is execute this on a data reader. I'm trying to remember the syntax, it's been a while. What this code will do is open a fast forward read-only cursor of that data, and then we can hydrate an object with it. We don't have any objects yet, so let's go ahead and create a simple object, or I guess they're called a PONO in .NET. This isn't the best way, but it's a very visual way to demonstrate what's going on. Now when I'm using date here, I'm actually mentally thinking date and time at the same time. You may be in an environment where dates and times are separate, so it can actually make a huge difference in database land. And to be technically correct, we probably should say date time or create date time. And since I'm making a training video, you're absolutely right, I'm going to do that. If this were in the real world, however, I wouldn't go through the effort. I would just leave it as date. Maybe that's bad design on my part. All right, and then we're also going to need that batch ID. We get some nice handy errors telling us that this non-nullable property might be null. I will make a default constructor and I will just get rid of this error. And that's okay here for our Pono. In the real world, we might want to take care of this in a different manner. All right, we've got our Pono, we've got our red. Let's do some more bad code. We would never do this in the real world, especially with a massive table. But again, for demonstration purposes, I'm going to show how to get the data, hydrate a Pono, and return it from a method. We will fix this as soon as we actually need the code. All right, list, customers. What we do now is we literally could hydrate this object. So we create a new customer. Do some copy and paste foo. Now this code, once our database is up, once our table exists, and once it's populated, will literally give us a list of all the customers in the database. It is that simple. Let's go back to Amazon and see if our database is ready yet. Why would you be backing up a database as empty? Come on, buddy. I wonder if I can actually connect to this right now. Open Management Studio, and let's try to connect. I'm not telling you what the password is, I don't care. You'll have to guess. Login failed for this user. That easy. We're now connected to a database. Let me show you why Management Studio Express is really cool, or Management Studio, or SQL Server Management Studio is really cool. We can literally list everything in our database. All right, let's create a database. What kind of data? What do we call this name? We're going to call this sample. And of course, now we're going to create our customer table. Two ways to create the customer table. I'm going to show you both ways. You have a new query. Do this the old-fashioned way, which has ID, we have our ID column, we have our name. How long should name be? We'll just say 50 characters because everyone uses 50 characters. We have our create date. Date time. I'm sorry. Don't think I have to write the word default. I can't remember. What do you think? Is this right? Don't remember. It's been so long and I didn't do this ahead of time. Oh. There we go. All right. And what this gives us is, oops. I'm going to comment this entire set here. There we go. And we could literally insert data. Ooh, that's a good point. We could have done this a little bit differently. I'm going to show you a different table here. Should have remembered that hotkey. Control K, Control U. I'll never remember that. In SQL Server, there is something called identity, which is an auto increment in MySQL. So now, everything looks identical, except we can insert data slightly differently. Specify, we're not going to specify ID because that's automatic. We'll just specify the name. We don't need the create date. We don't need the last update either. We just need the batch ID. And look, everything's inserted. Fantastic. Now I'm going to drop the customer table and I'm going to show you how to do the exact same thing visually and why it's so epically cool. Go to the database we created, sample, go to the table selection and select new table. And we're going to do the exact same thing, except here, where we're doing an RID column, which is our primary key, we're going to set this as an identity. And that's it. We also want to right-click, set this as the primary key. I neglected to do that previously, but I believe it was automatic. I'll actually show you how to do it just to be complete here. And not type when you're watching like this. And that's it. If we click save, this will make our table. We haven't specified a name, but it will prompt for a name. And we just type in a name and we will be complete. I'm going to not save this because I want to correct this. We had primary key, ID. See, I didn't have to do it. It automatically made a primary key because I had the text primary key. I wasn't even thinking. But if I neglected this text right here, this will also create the primary key. What's really cool is, technically speaking, you could make a multi-column primary key if you wanted to. Normally you do this if you have something called a natural key. For example, if you have social security numbers, which you shouldn't have, you can make social security number your natural key because that's not going to change, whereas a person's name might actually change. Last update date time, we have this table created. Let's insert our sample data again. And now what we're going to do is go back to C#. And let's see if this actually does anything. You will realize over time, as you work with database systems, you'll memorize how to do these connection strings or get relatively close. Uh-oh, you're about to find out what my password is. I'll give you a hint. It's 1, 2, 3, 4, 5, 6, 7, 8. This might work the first time. I haven't tested it because we're recording, you know that. Also, it's been about 30 minutes. I'm going to resnap so I can sync the audio so I don't look totally silly. And now let's write some code and see what happens. Any bets? Too late. Didn't work. What am I doing wrong? Go to Management Studio and we'll look at our connection string here. Oh, I know what it is. I've got to add a flag, but I don't remember the flag here. So let's use the internet. So we set encrypt to false. Let's see if this fixes our error. Login failed. Come on. Someone put too many numbers. There you go, look at that. Once we get our connection string established, we were literally able to pull the RDS database and bring back our entire list of customers. Okay, now what? Now I'm going to populate our customers table with just a handful of customers. The sheer number isn't important for this. We'll just make a I think if I need to do it in code because we need the code to show the update process, and that will be important in a second. So let's delete myself. Oh, you know what? This is a learning channel. I am going to show one other really crucial thing that everyone needs to know when using SQL Server Management Studio versus using Toad or any of the other tools. By default, implicit transactions are set to on in SQL Server. If you go to Tools, Options, and Implicit or Transactions, should be here somewhere. That's not it. There is a checkbox. There was. Actually, I said that, and it's literally unchecked right now. Well, SQL Server has implicit transactions on by default, meaning every statement writes the database. But this does not seem to be set, and yet it's still doing it. So, since I brought it up, I'm going to go back to the Googles. That's very interesting. The Google's saying exactly what I was saying, that when this is unchecked, we shouldn't have implicit transactions, yet it seems we do. All right, let's not worry about that. I'm going to show you why we care. All right, we see this customer is there. Well, if I do this, I sort of expected it to fail, yet I don't know what's going on. I think I'm gonna have to cut this. Maybe I'm doing it the reverse. Hold on. Let's do a second customer. Oh, there's your problem. I was doing it in reverse. Let's back up a second because I think I'm doing too many things at once. We have no customers. No, we still have the customer. So now, if we delete our customer, it shows deleted, but it's not really deleted. We have to commit in order to make sure the customer is deleted. And now that customer is deleted. We're going to set that back to the way we're used to. is very, very important to understand when switching between database environments, because this will definitely trip you up. And there's been so many developers who have accidentally deleted everything in production from this one little checkbox. Know the checkbox, know the checkbox. All right, let's make about 100 customers. Making the face, I'm trying to figure out how to do names. We'll do 10 first names, 10 last names assigned at random. And please, I'm not writing production quality C# code. I'm just writing the code so we can get to the tip here. What are some good first names? John, Susan, April, Adam, Mark, Veronica, Vanessa, Amber, Joe, 1, 2, 3, 4, 5, 6, 7, 8, 9, Charlie, leave that one gender ambiguous. And now we want some last names. I'm getting the error because I did the wrong quotation mark. And yes, as I'm sitting here doing this manually, it would have been a lot faster to search and replace. Now I'm already committed. That was brutal. I'm glad I don't have to watch that. Set some last names. Smith, Jones, Von Hammerstein, last names are much harder. Johnson, River, Brooke, I'm running out of ideas here. Smith, Jones, Van Hammerstein, Johnson, River, Brooke, King, Adams. I already have Smith. How about Jackson? And Tyler. Okay, now I'm going to write a function to just generate a last name. I am creating a random variable. Random generates random numbers or pseudo-random numbers. And the reason I provided 1 is I'm providing the seed 1. So every time we run this code, it'll be deterministic and give the exact same random numbers. So we'll always get the random set. So it'll make our life a little bit easier. All right. Mine is blinking. Mine is blinking. I'll get to it just a second. What we want to do is just concatenate a first name and a last name. Just copy this code. And now we have a method that will just give us a name. Let's see what happens. It's pretty slick. It just worked. I was kind of expecting it to crash. Look at that. We got some really nice original names here for our nice original customers. Now, what I want to do is double check to make sure our customer table is empty. And we're going to insert random customers. When I create this method, insert random customers, I'm also going to demonstrate the concept of parameters in SQL. And SQL parameters help prevent SQL injection attacks. Before we get there, let me resync my audio. We're getting long. And OBS will lose the sync, so this will set us back in sync. Okay, we're going to use parameters. Parameters prevent SQL injection. The way this method will work is if we pass a customer object, we will insert that customer object. An interesting error here. I don't want to dive into this error because this video isn't a C# video, but I feel compelled that I must. Because we didn't declare ID as nullable, we could have a situation in production if you use this style of code where someone might pass in an actual live customer that's already in the database, and there'd be no way to tell that this customer is already there without checking. Because you see there's already a customer ID. Normally the way I would handle that is to use null, but we try to avoid nulls these days, so who knows what we should do. Your mileage may vary. Look for other approaches. I'm just kidding. There's a million ways to do it, and that's one of the benefits to ORMs is you don't have to address that challenge anymore. Let's insert. The way we're going to insert is open a connection. Again, the using block, if I didn't mention earlier, will automatically dispose of this connection, and dispose means close and get rid of the memory it's using, so we're not using valuable server-based resources whenever this goes out of scope. Also in SQL Server, this defaults and we'll use a connection pool. So it doesn't technically go completely out of scope, but the moment we end this block, another block can reuse the code or the connection, making it going a lot faster. All right, we need a command. What are we going to do? Well, we use native SQL. We're going to insert into customer, provide the values we're inserting. We can't insert ID, so we'll insert name. We shouldn't do the dates because those are automatic. We will do the batch, and we'll declare this batch number 1. This is our very first batch. We haven't done anything before. Here is where the parameters come in. I'm using name with the @ sign, and batch ID with the @ sign. This will tell the code to use the parameter values we provide. So let's create a parameter. Remember we said this is 50. And you don't have to do this for anything except for text or binary field setting the length. And I don't even think you have to set the length. I just like to do it to be explicit. And here, because batch ID is always going to be the exact same value, we'll just set the value hard-coded to 1 for this batch whenever we're inserting. Oh, good catch. No, we're not going to do that. Why? Because I want to reuse this code later, and if I do that, I won't be able to use the code. Okay, we've got the customer. Let's now set values. Finally, we execute. And remember what we were speaking about earlier, the transaction is automatically on, so we don't have to commit here. I want to add another cool feature here. We're friends. I want to show another cool feature of SQL Server and these parameters. Let's add ID. Now I know we're not inserting the ID. We're going to get the ID, and it's going to be really slick. Set the direction to output. Now in our statement, we can set the ID value to scope identity, and then this code would literally set the ID value of the object, which we don't need, but it's pretty cool nevertheless. Now let's test to see if this code works. And again, I realize we're 47 minutes in and we haven't gotten to the cool trick. I'm walking through the tutorial to show everything. I might actually have to take a break and come back in a little bit. I'm being harassed here on Slack, as you can see. I thought I muted it, but I guess not. We'll do 100 customers. All right, taking bets. Code gonna work the first time? No one wants to take that bet? I don't know either, so let's find out. Kind of worked. I forgot to do the ID correctly, so oops. But we can prove it worked here just by going to too many windows opening. We can prove it worked by Manage Studio Express. Well, look at that. We now have 100 customers with a batch ID of 0. Why is the batch ID 0? Because the default value from integer is 0. We didn't set that. So, works better. I think 0 is great because it lets us know that there are 0 in here. Now, we know load customers works. We know the batch works. Now we're getting to the fun part. Here's the fun part. And let me be rude. I'm going to take a 5-minute break and I'm going to come back. You won't actually notice. I'm going to cut it in as if I didn't take a break. But I'm going to take a small break, come back, answer some messages, and then do another recording. And we're going to get to the fun part. So part 2, but you don't have to wait. I'm just going to cut it right into the same video. Stay tuned. Or don't stay tuned. It's next. It's right now. Welcome back. I hope you enjoyed the break as much as I did. Now, unfortunately, it wasn't a mental break because I was thinking. I completely forgot something. For the demonstration purposes that we're about to do, well, it sort of makes sense that we're going to change some values in the database. So I have to have at least one value to change, and I don't want to change the customer name. So we're going to create a column for value, and we're just going to randomly set a customer value. It's really unimportant. Delete all the customers. Now let's take advantage of the visual tool and let's literally update our columns without having to remember how to add a column. Click Design. And I want value. So we'll do a value We'll call it a decimal. Decimal is basically money in SQL Server, which means for digits. We're not going to allow nulls. And we will save that. The reason it's crashing or waiting for 30 seconds is because some reason there's a transaction open in the other tab. And it's going to time out here in about 15 seconds. I thought we got rid of that implicit transaction. I guess not. The default 30 seconds. I don't actually know how long it's going to wait here, but it should come back now here in a moment. Thought that was 30 seconds. There we go. And so we don't make that mistake again, I'm going to close this window and we'll just use a new window for edits from now on. Now let's go back and do this design. See how fast that was? It's because we had that open transaction. And knowing about transactions will help you a lot, because if this would have just crashed and we didn't know about transactions and the implicit transactions, what we're playing with, it's like, what's going on? All right, go back to the code. Modify my class file. Modify the load code so we don't forget. This is another great reason why people love ORMs. I'm just not a favor. Is this sort of an update? We just one click, everything updates, and we don't have to change all of this associated code. But it's great here because now you get to watch and learn some of the background about why ORMs were created and what we need to do when we're working around ORMs. Notice I put the word money instead of decimal. This is a map to the decimal type in SQL Server. Oh, we did make a mistake. This should have been batch ID. Good thing we have unit tests to catch our work, huh? All right. Let's give a random batch ID. No, let's give a random value. Between 1 and 10,000. I'm going to do ID so we can see if this even works. Nope. Forgot to add the value column in the values clause, and now see we are actually getting the ID value back from the database. Almost finished. Epic. Okay. Demonstrate that the data is here. Are you familiar with database design techniques? And I believe the word is atomic transactions. I'm going to pull up a browser here instead of using a graphic and just demonstrate the first thing we find from Google. We're going to say atomic transactions, SQL Server. Atomic transaction is an indivisible, irreducible series of database operations such that either all occurs or nothing occurs. It's a guarantee to say what you think happened, happened. What this means is when we're updating data, you go to update a record, the database acquires a lock at either the table level or the row level, locks that data, then the database changes the data, then the database writes the data to the log file, then the database writes the data to the data file, then the database compares the data file to the log file, then the database marks the data valid, and then your transaction can be completed and we get to go on to the next item. I said that laboriously slow, maybe slightly inaccurate, I can't remember, I haven't looked it up in years. But the reason I said it so slowly is because it is slow. Every time we do one of those operations, it's a slow operation, which means if we go to update our customers and we're going to update our customer tables, we can update, let's say we have 100 customers, we need to update 35 of them in batch. That's going to be 35 row level logs, or maybe even a table level log. And it's going to be kind of slow. But this is how most ETL systems work. And to bring it tactfully, I'm literally going to show here what an ETL would do. You would write update customer set value 1, 2, 3, 4 where ID equals 5, and we're also going to set the batch ID because we're changing the batch ID literally right now. And this is how most ETLs are built. They'll do one update at a time. And they'll update, I forgot to update the last update. We'll do it one last time, just to pretend we did it the correct way. So we'll have our batch ID, we'll have our last update time, and we'll know that that value is updated. And this lets us go back and verify that the ETLs are completed. This is a very slow process. However, in the traditional ETL design, this is a very critical process for many ETL managers, and this is what they love. They love to be able to go back and validate that each appropriate record was appropriately updated. And if they can't do that, well, they're not happy. And it's like, oh, well, it must have failed. We can't tell where it failed. And since we can't tell where it failed, our data is inconsistent. If our data is inconsistent, we got to start all over again. All valid concerns. So, how do we insert the data faster? Can we insert the data faster? Can we validate success? Yes. Remember the process I described about our database. There's a way to short circuit that process, ignore all the extra checks, do all the work, and then write to the database table. It's called a bulk insert. The problem with the bulk insert is if the bulk insert fails, your table's in an inconsistent state. And if your table's in an inconsistent state, well, you defeated the entire purpose, and now you have to start all over because you have an inconsistent table. Not a good place to be. So the question is, how do we solve this problem? I'm not expecting to know, but I'm trying. I didn't write a script for this, so I'm trying to put the script together in my head while we're talking here. I'm not expecting you to know, and I'm trying to decide in my head whether I should show the bulk insert code first or show the new technique first. Let's write some code for updating first in C# to show how to do this update statement in our code with a customer object. Then we can come back and I'll show the technique to get around having to do the update. Let's write a method for updating a customer. Now you might be asking me a question. You say, Ennis, what happens if we try to update a customer that's not in the database? Nothing. That's exactly what will happen, is nothing. It will ignore the command. And the only thing that we update now are the batch IDs, the value, and the last update date. You might be asking yourself, why am I adding brackets all the time for some of these field names? The reason I'm adding brackets is some of these fields are protected or reserved names in SQL Server. Adding the brackets just explicitly tells SQL Server this is a field. I don't think it's actually necessary. It's just a long-worn habit. We set the value. We need to set the batch ID. And this should be the code we need to literally update. I'm going to copy some parameters, bring them back up. We need ID, but the ID is passed in now. We don't need the name. We still need value. We still need batch ID. Now it's a mere exercise of updating this information. ID, value, batch ID. Now we literally should be able to update a customer and set these values. Let's find out. What's really cool is we don't actually have to load the customer from the database to do this. We'll take advantage of customer number 5 again. We'll say we're on a batch ID of 42. Probably bad practice because I'm just making this up, we'll forget. And the new value is going to be 100. This should update the customer, but let's go and look at that customer's data first so we understand. The value is 1, 2, 3, 4, so now it should be 100, and this should be 42 for the batch ID when we're finished. It crashed! It crashed because I used get now, and it's actually now, I believe. It was now. Oh, let's get date. I don't know what I'm thinking. Boom, set 100, set batch 42. That works. Okay, let's go back to some more code here because there's, to be complete, and I hate having to do this, there is a problem with this code. And that if we're going to update a bunch of customers using this method, we don't want to open the connection every single time. We don't want to create a command every single time. We want to reuse that information. So what we'd really want to do is be able to update a bunch of customers at once using this process. We can literally violate our dry principle since we're doing an example here and just copy and paste. There. And this would let us update a whole bunch of customers at once, which is kind of our goal now. So we're able to update an entire list of customers, which means if we are down here in our code and we've processed a new batch file, now we have to update 150 customers, we can provide that data in a list to that update, and we will update the 150 customer values or the 30 customer values that are appropriate into our database, exactly like we're expecting. Works fantastic. If we're traditional ETL or we're in Java, we're probably done now. But Ennis, we're an hour and a half into this video. Where's the trick you promised us? Okay, let's get to it. Updates are slow. Because of that, there's a nifty little feature called bulk insert. Bulk inserts, again, violate all these principles, just write and just call it done. So I'm going to write a method to do a bulk insert on the customer table. And I'm going to cheat ahead of time, and I'm going to provide the table name, and you'll see why in a little bit. Now when we bulk insert, we have to turn identity off because we're going to insert the identity values that we already have. We have to provide that value. It can't be generated from the database. And then we have to turn that back on. And the data is going to just reside on top of our existing data. Which means if we do a bulk insert on a table that already exists with data that already exists from that table, it will not work, or it'll duplicate the data. And there's where the rub comes in, is to do this the way we're describing, we would need to delete the table first. Very risky. I'm going to write the code. Then I'm going to load the customers, change some customers, update the customers using the bulk insert and the delete method, and you'll see what I mean about the risk as we're getting there. So let's just get to it. There's a lot of talking and not a lot of writing here. So we need to open our connection. We need to make our command. We need to complain that it got rid of our bracket once again. We don't need a command. I don't know what I'm talking about. I'm trying to remember how to do this. We need a bulk object, set the table name, disable or enable identity insert. Maybe that's automatic here and I just can't remember. I'm gonna have to check on the interwebs because I don't want this to crash for everyone. Keep identity. That is not a valid option. Okay, so we don't have to provide it. By default, it should work. We'll find out really fast if this works or not. Okay, so now we have to do a column mapping. And this is really irritating because generally it's identical one-to-one if you're doing things the easy way. So you have name, value, create date, time, last update time, and then batch ID. Now, we have to make a data set that has this information. You don't actually have to have a name here for this table. Almost done, almost done. I know you're about to turn away. It's a lot of copying and pasting, so I apologize. Now we have to hydrate this data set with our customers. For this example, I'm not going to do this in the batch processing. In the real world with large data sets, you have to do this in batch processing, or it just isn't going to work. Okay, let's add. The records. ID, customer.name. This gives our data set populated, and now it's a simple matter of writing. This should work. Famous last word. So let's test to see if this works. We will load our customers. Now, for the first 10 customers, let's change some information. And we're going to change the value to be 500. Or change the batch ID to be 3. And we're going to change the update time to be now. Now we should be able to bulk insert our customers. To the customer table. I don't think this is what we want. I think that this is going to crash because we did not delete the data first. However, I'm willing to do an experiment because I can't remember the answer. Let's find out. Wow, didn't crash. Let's see what it actually looks like in the database. You notice our problem here, don't you? We have doubled our customers. And the issue I was telling you about the identities, it used the identities even though I wasn't expecting them to. So let's delete these. Let's try it again. This time we'll set the options to use our source or destination or whatever the value should be. And then we should get a crash, which is really what I'm expecting. That's what I want to see. This crashed. Now we look at the data, and we'll see that the data is still correct. All right. Now let's get dangerous, as Darkwing Duck says. Here is where this technique with ETLs gets really dangerous and why ETL managers do not like this technique, traditionally. To do this technique in the traditional manner, you have to delete that table first. So what we're going to do, we have our open connection, and I'm going to issue a very, very risky command just for the sake of making this work. I'm going to delete all the data in the table. And I spelled truncate wrong. Now, if we look at our data, you can see there's still only 100 records. And we can see we have appropriately changed the batch ID for the first set of records, and we have appropriately set the new time for the appropriate records. And we've appropriately set the value like we set for the new records. Okay, we're here. Let me resync the time. "90 minutes in, and now we're going to get to the good stuff. Okay. In database technologies, in databases we have tables, and then we have something called views. A view is a visualization of a table. Now, what's really interesting, views and tables can be used nearly synonymously. Watch this. I am going to rename our customer table to customer A, and now I'm going to create a view Nice. This view can be updated as well. So watch this. So we've updated the view. What this means is, behind the scenes, we can change our actual table without modifying any code to be a view. Now you say, well, it's okay, well, who cares? Who cares, right? Well, check this out. we will I'm thinking I'm scripting our customer A, and I'm going to make two new tables called customer B and customer C. I don't like this, so I'm going to rewrite it to the way I want it to be, just because it's going to be easier to do this and the database will take care of the work behind the scenes. Looks identical, right? Let's create customer table C. Looks identical, correct? Okay, now we should have A, B, and C. Fantastic. B is empty. C is empty. A is the current. What we do is we're now going to modify our code to see what's the active view. When we know the active view, then we're going to do our changes in an or we're going to see the active table. Then we'll make our changes in an inactive table. We don't want to make our changes to a live table. Then we can compare the live table to the new table and see if everything was successful. And then once everything's successful, we can merely alter the view. So now I've got to remember how to do this. Let's get the view text. I believe this is it. Excellent. Which means if we execute this statement, we can find out which view we have in code. So I'm going to create a method. And again, I'm really sorry we're doing this one monolithic class file here. This is horrible and you really don't want it in production, but for the sake of the video, I guess it's a necessity. So please don't look at this as I would check this into production. Please, please. Get current view. I think of the best way to do this. I've got to execute a reader. All right, well, maybe there's not a view in the database, so we could return a bad value here, which is not good, but we'll pretend, for argument's sake, that it has to exist. And there's no way it can't exist. Otherwise, it's going to get infinitely complex here. So we're going to read that definition column. We'll say, okay, put that into temp. And then we're going to say, if temp contains customer A, customer B, customer C. The astute among you will say, well, what if the capitalization has changed? So let's just be lazy. So if it contains customer A, now we can identify our current view. When we have our current view, we can then find an empty view and truncate that table. I'm gonna put it a different place. Still very dangerous code, by the way. So if we're going to be technically complete, what we would do is double check right here and say, and we just crash because we don't actually want to take out the database. And we can test this to see if it works. So let's truncate customer A and see what happens. I want to keep this code because we're going to reuse it here in a second. Let me resync the audio. It's not a big deal. We can recreate it if it truncates customer anyway. So, but yeah, even though we're doing an example here, I don't feel comfortable doing this. Customer A. Okay. So now I feel more comfortable doing this. You killed us all, you arrogant! All right. So now we protected the truncate. And let's see if truncate will work with B and C. Notice truncate actually requires special permissions on your database. You can't use it with just a generic user. But for this example, we're using the DBO user, so it doesn't matter. All right, now what? Well, we can truncate our table. We can get data. We can update the data. We can bulk insert to our new table. So let's see what that looks like. We have loaded our customers. Let's get our current table. Now, what do we need to do? Well, we need to write a method to give us the non-current table. I'm going to skip that, and I'm just going to hard code this to now because this video is getting kind of long. Our new table is going to be customer table B, or customer B. We're going to update our data. Again, we pretend that we actually did this from a CSV file or from our ETL. we're going to update our data. We are going to truncate our new table because we don't care about that new table. Then we are going to bulk insert into our new table, and let's just see what happened. You may notice from 40 minutes ago, this was nearly instantaneous versus inserting and updating 100 records. Customer table B now has 100 records. Customer table A now has 100 records. Now, we're not going to write the validation code, but we will notice, look, we forgot to set our batch IDs. So clearly this is wrong and we can't use it. So what we'll do is this ETL has failed. So we marked it as failed, or our automated test would have caught this as failed because something didn't happen. And we just roll back, send an alert email, let someone come in and investigate it. But for our purposes, I'm going to change our batch ID to be what we expect. All right. We're going to run it again, see what happens. Again, relatively instant. That's pretty cool. All right, we've got the new batch ID, we've got the new update times, and A still exists. Excellent. Now what? Well, in our code, we would write a method that I'm not going to write. I'll just do a stub so we can pretend here. Validate new table makes sense. And then you can pass in and all we're doing is providing some sort of sanity check to say, hey, is this sane? Is it rational? Does everything make sense? Because mistakes are going to happen, but we can actually detect after the table is written that everything's there as appropriate. And what's really cool is, this is the cool part. Because we're not making transactions, this is significantly faster. And that's what we're trying to avoid is the transaction round trip. And yes, it does use a little bit more memory. Yes, it is more complicated code, but we're avoiding that transaction, making these lightning fast. So let's pretend that this makes sense. Our old table, we have current table, we have our new table, we have our customers, and I guess technically speaking, maybe this would be how you could call this method. I probably had to put it in here. So now we say, okay, well, this makes sense. Now what? Now we need to swap our tables. Or swap our view, I apologize. The view should already exist, so we should update it versus delete it, and this should work. In fact, I'm almost willing to try it without testing. Let's see what happens. No! Why'd y'all let me do this? The command's alter view, not update view. Let's see what the data shows. We have B as expected. We have A as expected. What does our customer view look like? Success. Now, let me resync here. I'm gonna resync. Epic. All right. I'm gonna tie this in to how you would literally go about this in production, because this is a one table example. It's not very effective because in an ETL scenario, we have partitions. We have hundreds of tables. And that means we have to take this code and we'd actually look at the individual partitions. For example, let's say we have a partition for every week and we need to update partitions. Well, then you would have to use this method on every partition that updated, and then you'd have to be rational with your code based on the complexity and say, well, wait a minute, if we're only updating 1 or 2 records, let's just use an update method. So if you're updating 1 or 2 records from last year, just call an update. But if you're updating from last week and you have 3 billion records, you can use this new method, which is significantly faster. And at least with SQL Server, it's really easy to create distributed partition views, which is the natural way we access all these different views with all these different tables. So all that works really, really well. That's it in a nutshell. It's a near 2-hour video. It's long. I wrote a lot of code. I introduced a lot of new concepts, and I showed something that every ETL manager in the world is going to hate. However, with this technique under your tool belt, you will now have another technique that you can use when this is appropriate. And that's the most important, crucial piece of information I can provide. Use when and where appropriate. This technique may not be appropriate in most environments. However, I've literally used this, and the code that I did is still in production over 10 years later, and it's working fantastic. That should say something about how reliable this technique is. Questions, comments, put them below.